Hello, working drawing students. This is the first lecture on Lesson 1. If you look in Blackboard, there's 2 presentations for Lesson 1. This one's on Chapter 6, which has to do with orthographic projection. The other presentation is for Chapter 8 and 9, which talks about section and auxiliary views. So this is the first presentation. It's about orthographic projections. What I want you to do, first of all, is to look at your objectives for this lesson. Okay, and you'll see this in the materials folder. So this is your objectives for Lesson 1. These are the things, after you're done studying this presentation, these are the things that you're supposed to know. These are the things that I will be testing you on. So every lesson has an objectives. For studying the lessons, it would be best if you were to print out the objectives. That way, as you're studying, you make particular note of these particular items and make sure that you know them. So these are the things. So some of these objectives are going to be from Chapter 6, some are going to be from 8 and 9. Some Chapter 6, we're talking about the principal views of projection, difference between first angle projection and third angle projection, sketch views, that'll be part of your assignments, and then these next items here will be the ones from the section views, Chapter 8, and then down here, these will be the terms I want you to particularly notice while you're studying your presentations. These are the terms that will be on the tests. These are the terms that you need to know. These are the terms related to these objectives that will be for your learning. Okay, so let's get started with this. Understanding projections. Here we have a part on this side, and then we have a projection of that part. This is what you need to know to make drawings that interpret the design of a part. Okay, you know how to create projections and understand the arrangement of views. This is crucial to understanding how drawings are presented. This slide here has to deal with your first objective, which is list the 6 principal views of projection. And these are the 6 principal views. We have the top and the bottom, the rear and the front. We have the left side and the right side. Those are your 6 standard views, or the principal views of projection. Now let's talk a little bit about projection. Essentially what we're going to talk about is this glass box, for instance. Okay, I'm going to go to the next slide. So we have a glass box drawn around our part. Okay, and the views that we generate are projected on the inside, from the inside of this glass box. Okay, so that gives us these principal views that we're looking at. We can get the top view, we can get the bottom view, we can get the front view and the back view, and then the 2 sides as well. So essentially this is how we arrange orthographic views. This is how we conceive of orthographic views. And then to create the orthographic projections on a drawing, we essentially unfold this glass box, and then that arranges the views in a logical manner. Okay, so in this case we have a front view, a right side, left side, rear view. Now, one of the things that we talk about is transferring depth. Okay, so if we look at the left side view, the depth of the part is transferred up to the top. So actually this dimension across here is the same as the dimension across here. It's a way of transferring depths. Now when we create a drawing, we're not going to put all of these views on. Typically on a part like this, we would only need like 3 views, whether it would be the front view, the top view, and the right side. Typically we just need enough views to completely define the part. And that's this next slide. We're kind of talking about orthographic projections and how to lay out the views on the drawing. And it's done using these so-called folding lines. Again, it's from the glass box concept. And then we come over here and show how to unfold these things and display the three views that we need for orthographic projection. So this is essentially what we end up with, is we end up with one view here, and then the other view to completely define our parts. Then we're going to talk a little bit about transferring depth dimensions. This has to do with your first drawing class, where you spend a lot of time on the board, graphics drafting board, generating these 2D drawings. You're going to use these same techniques here, but this has to do with transferring. Again, this would be a review for you guys. Okay, necessary views. The front, top, and right side views arranged together are called the three regular views because these are the views most frequently used. Okay, this is typically how you do. A sketch or a drawing should contain only the views needed to clearly and completely describe the object. Okay, so we're not going to use all 6 of the principal views here. We're going to use typically just these 3. And then we'll go on and talk about other situations, namely this one over here, where we have a part, which is a cylindrical part. You could tell by this diameter symbol. And then this over here is a square, and it has the dimensions on it. So this is a simple cylindrical part. I was able to, or they were able to in this one, completely define this part with only one view. Okay. To make efficient drawings, we want to use as few views as possible to do what we need to do, which is convey all the necessary information for the part. So in this case, we can do this with just one view. I'm going to talk about third angle projection versus first angle projection. First of all, I want to say about third angle projection is that this is how most drawings are done in the United States. Third angle projection. This comes back to how the box was unfolded when we did our the glass box, and we tried to unfold it to show the views. Okay, so in this particular case, what we're looking at is the view of the object displayed from the inside of the box. So it's projected from the object inside to the outside of the box. This is what I think of third angle projection. Then we have over here, we have the symbol. Okay, so one thing about first angle or third angle projection, it's very important to know how the views are displayed on the drawing. So third angle projection, we look at this symbol here. It's a conical shape with flat ends. So in this picture right here, we're essentially looking at, I'm going to call this the front view, and then I'm going to call this the right view. Okay, so what we're doing is we're looking at the cone here essentially from the left angle. So we're viewing this cone from the left-hand side. This is third angle projection. This is how intuitively you would think about how parts are displayed on the drawings, how the orthographic projections are arranged. So if I'm looking at the object right here, then my right side view is projected from the object to the inside surface of this glass box. This is third angle projection. This is what you're most familiar with. And the other one I want to talk about is first angle projection. This is how it's done in Europe. Okay, and actually it's quite backwards. I mean, for me, what happens is, see how the right side view actually shows up on the left-hand side of the part. So it's like counterintuitive for me because it's backwards. So what I'm talking about here is, over here we got the right-hand view, and it's shown on the right-hand side of the part. But if you're talking first angle projection, the right-hand view is on the left side. So it does get a little bit confusing. And then here's the first angle projection symbol. Okay, so it's obviously looking at it from the other direction, which means that this view here, that I can see both circles of this cone, is now coming from the other side. Okay. So let's talk about hidden lines. Hidden lines are thick, dark. Thick, dark lines represent features of the object that are directly visible, whereas dashed lines represent features that would be hidden behind other surfaces. I'm going to stop right here to keep the videos short. Thank you. I'll pick up on the next video.